This schema presents the forecasting scenario. The metadata management energy data is published in the DDS bus and is processed in real time by the forecasting algorithms. The results will be available for the distributors and retailers to manage the energy demand and to purchase energy in the market. The MDM injector simulates the performance of a real MDM system. Once the best available energy data is calculated, it is published in the DDS bus and will be accessible to other systems. Initially, only MDM energy data is stored in the database. The MDM injector is connected to the database to get the energy data. The retrieved energy data is the same as the one stored in the database. Once the injector is launched, as soon as the energy data is retrieved, it is published in the DDS bus. This energy data is consumed by the forecasting algorithms. The target of these algorithms is to predict the hourly consumption of different customers for the next 24 and 48 hours, in order to perform demand-side management. These figures show the different load profiles of several buildings. As we can see, there exist significant differences, depending on the type of day and hour, and the consumption profiles. The overall methodology is composed of two parts: classificator and forecasters. On one hand, we receive MDM energy data through the DDS bus and store it in memory. Through the classifier, we get the type of day and we infer its information. This provides the forecast for the next 24 and 48 hours. If the work calendar is available, this is the best classificator to know what type of day to predict next. We use a SVM-based model with a short training. The speed at which the model works is high, allowing the algorithm to adapt quickly to changes in consumption. The database persistence is responsible for the storage of all the energy data that flows in the DDS bus. This energy data is saved in a historic value database. Initially, only MDM energy data is contained in the historic value database. The database persistence is composed of the F24 and F48 subscribers. These subscribers are constantly listening to the energy data, and as soon as the data is received through the DDS bus, it is stored in the historic value database. Finally, the 24 and 48 forecasting values are stored. The distributor will be able to visualize the real-time data as well as the 24 and 48 hours of forecasted data in a real-time website that has been developed in this project. In order to do this, the website is connected to 3 subscribers, one for the real MDM data and the other 2 for the 24 and 48 hours of predicted data. These subscribers are constantly listening to the energy data, and as soon as the energy data is received through the DDS bus, the energy data is displayed in the dynamic chart web. On the other hand, the retailer will be able to view the predicted energy consumption that is stored in the repositories in order to analyze the results of the forecasting algorithms compared with the real consumption. The user has to access as a retailer. In the main page of the retailer, the user has to click on the forecasting tab. A measuring point from the list and a date must be selected. The page will display the energy data based on the selected criteria. The energy data is retrieved from the historical database through SOAP web services integrated in the ESB. Results can be displayed in alphanumerical and chart mode. The MDM, F24 and F48 energy data are displayed in the same plot.